I think if you people are able to think on this question, we can do. Yes, this is the great question. See, this is a property of flip-flop. This is a property of transistors, right? That how you no, that is not rise time and fall time. You are taking it differently. So you assume that this is the clock, right? And this transition happens in this manner, exponential, right? For example, e raised to power minus t by tau, right? Tau is the property of the flip-flop WL ratio and everything, right? So I am telling you very vaguely, right? So for example, I assume that in this clock transition, uh, at 0.53, I say that at 0.53 of the amplitude of this charging, I say that this is a middle point at some point, right? This is a property of flip-flop. And then it takes 2 ps to charge from 0 to 0.53, and it takes 1.1 ps to charge 1.53 to 0.97 of the amplitude, because digital electronics also have VOH and VIL and these things. If you want, I can explain that also. So how digital electronics works is like, for example, this is 0 and this is zero point 0.2 volt, and this is zero point 0.8 volt, and this is 1.0 volt. So any value between these two is assumed as a high, any value between this assumed is a low, and a transistor level. So how much time it takes to go to its VIL level, and how much time it takes from uh, uh, VIH level, and how much time it takes to come out of VIH and reach the half of it, right? So that's how this is the minus t by tau functions, and hold and setup. These are hold and setup times, not the rise time and hold times. Okay, so the time it takes to reach the one, right? This is the middle point. So if, for example, it take 2 picosecond to reach this, and reach to 0.1 for 2 picosecond to reach this, right? And it is possible that they can be symmetric, but they are not symmetric many times, but it can be 2 or 1.9 s 1.9 and 1.6. So there can be any relation, that is a property of the library you are using, and what which technology node you are using. But this is not related to the rise and fall time. This is rise only, but at what rate you are rising, and what rate at what edge. For example, this is a clock going in transition from like this to this, right? But any time in the waves, you see that there is a process going on. So where at which point you are saying this process is going on, right? It can be 0.53 of the amplitude, or 0.49 of the amplitude, right? These are the relationships of the synthesis libraries, and what I forgot it. Annotated delays, right? When we do synthesize and runtime, we get the SDF files, standard delay files included in the simulation, gate level simulations. If we go in depth of gate level simulation, I will explain them